Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 11 of Gardeners of the Galaxy, a podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. My guest on this week's show is Christine Escobar, VP of Space Lab Technologies, who recently sent an exciting plant experiment into space on a New Shepard rocket. Hi Chris, thank you so much for coming on to Gardeners of the Galaxy to tell us about your really exciting work that you've been doing. So you're VP of Space Lab Technologies. Can you explain a little bit about what your company does?
Yes, I would love to. The Space Lab is a very, very small business that we are located in Boulder, Colorado. And I co-founded this company in 2016 with my husband, actually. His name is Adam Escobar. He's our CEO. And together, through founding this company, we develop sustainable technology for human space exploration. And that means that we provide the tools and the resources for people to live and work in space productively and efficiently and reliably. Our company also provides engineering support to government and private companies that share with us in that goal.
Right.
And that includes things like life support systems that we can provide, thermal control, environmental monitoring. We do crop production systems, which we'll be talking about today, and other food systems technology. It might even be other kind of accommodations that you might need for crew health and comfort and support. We even provide telemetry systems and communications, data processing technology. We even do science instrumentation. So we do a variety of different types of technologies that all work together to support that goal of sustaining human space exploration. So in a way, I think you could say we think of ourselves as space habitat outfitters. And what really sets us apart from other companies, I think, is that we envision this sustainable approach to space exploration.
Yeah.
We think that deep space exploration is really a tremendous sustainability challenge because it's so expensive to launch anything into space.
Yeah.
And it's so hard to go back home if your equipment breaks down. So the more that we explore and the further that we go, the more it pays off to reuse and recycle and regenerate consumable resources on the spacecraft, rather than carrying it all with you and then throwing away all of your waste. So if we want to continue going out exploring farther into space for longer durations, our habitation systems really have to be reliable and robust and efficient. And those are really the cornerstones of what we do at Space Lab and our design philosophy. So our ultimate vision at Space Lab is to one day build a completely self-sufficient space habitat that's Earth independent, would be our dream. So we believe that if we can achieve sustainable habitation of this uninhabitable environment, we should also be able to achieve sustainable habitation of spaceship Earth as well. So that's
absolutely
goal for us.
Wow, that's some vision.
Yes, it is.
Okay, so you have just had an experiment launched into space on the New Shepard vehicle, and that's called the microgravity lilypond. So that sounds really exciting. That's an experiment to grow a tiny little pond plant called duckweed, which a lot of people probably think of literally as just a sort of a weed that grows in the pond. So why are you sending duckweed into space?
I think it might be surprising to some people that NASA is actually supporting space agriculture technology, but as we all know, there's really great health benefits of eating fresh produce, and that's especially for astronauts that are living in this really stressful environment, both physiologically and psychologically. And so if we're going to grow vegetables to feed our crew on a spacecraft, the first question that we ask ourselves is, what makes a good space crop? What are good crops to grow?
Yeah.
So I'll talk a little bit about what that is for a moment and then take you back to why we like duckweed. But for a good space crop, we need to be able to produce a lot of nutritious material with minimal resources.
Yeah.
those crops should have a high nutritional density and taste good. If they don't taste good, you won't eat it. A high harvest index, that means that they don't waste a lot of energy producing parts that you can't eat, like stems.
Yeah.
And we want plants that have a high yield and that consume minimal energy. Also, we want a lot for our space crops. They need to grow fast. They can't require a lot of big space and infrastructure and hardware because there's not a lot of space available on spacecraft, and it's so expensive to carry mass. And they need to be tough. They need to survive potential shifts and extremes in environmental conditions that might happen. And also, if they're easy to consume, like you don't have to take a lot of effort or time to maintain the crop or prepare it to eat, that's nice as well. So for all of these reasons, we find that duckweed plants are surprisingly attractive as a potential space crop to supplement crude diets.
Okay.
They check off all of those boxes. Duckweed is actually one of the fastest growing plants on the planet. It will actually double its biomass in 2 days if you grow it under the right conditions.
Yeah.
It's the smallest flowering plant on the planet, meaning it doesn't take a lot of infrastructure to support it, and it's completely 100% edible. It doesn't have any inedible parts. You can eat it raw. You don't have to do a lot to prepare it, and also it's easy to grow it. It just reproduces vegetatively. It just buds and copies itself. It's very tolerant to environmental extremes, and believe it or not, it's also very palatable. So it is consumed regularly in many Southeast Asian countries like Thailand. And it is really nutritious. And this is what really shocked us when we started looking into this very fast growing little plant. It has up to 45% high quality protein, similar to or even better than what you might find in soy. It has all of your essential amino acids in it. It's also a good source of certain vitamins like A, E, and K. And it has also powerful antioxidants like zeaxanthin and lutein, which is also really great for protecting astronauts from exposure to radiation. Those antioxidants are really important. Also, duckweed is a good source of omega-3s. So there's a long list of all of these nutritional benefits that we found were really impressive. So we're working really hard now to establish this incredible little plant as a nutrient-dense space crop.
Wow. That's amazing. Okay, so that's why we've got duckweed. So can you tell us about the challenges of growing an aquatic plant in space? Because obviously that's not its normal habitat.
Obviously not. Space isn't our normal habitat either, nor for any other regular types of plants. So overall, I mean, space is an uninhabitable place, right? There's these extreme temperatures. There's space. There's no air to breathe unless you're on a spacecraft.
Yeah.
There's high levels of radiation. Oh my goodness, there's meteoroids that drift through materials. There's, of course, there's this lack of gravity and that stresses us, our systems and confuses biological systems. So we have a spacecraft or a space habitat, and that'll protect us and protect our plants from those elements. But we still have this lack of gravity, and that presents a big challenge for plant growth. In space, when you don't have the force of gravity pulling water down, other forces will take over, like surface tension or capillarity. And what this means is that it's really hard to get water to go where you want it to in space. So an aquatic floating plant like duckweed, what it needs is a stable water surface to grow on. And it needs that stable water surface to provide it not only with water, but its nutrients for growth. And it also needs an air supply over the plant to provide it with CO2. So keeping this stable air and water interface that doesn't submerge and drown the plant, that's the big challenge in microgravity.
Yeah.
For a submerged aquatic plant that grows under the water, CO2 provision is also challenging because of the lack of gravity. You don't have convection to stir the gases in the water. And also that lack of gravity, it makes it very hard to separate the water from the plants when you're ready to eat them. When you're ready to harvest, you can't just pick the plant up out of the water. The water kind of all comes with the plant. So when we learned about these amazing duckweed plants, by the way, also duckweed plants are known as water meal. You might hear that term used, or water lentils. So I might go back and forth with those. But, If you're going to be growing duckweed plants, we need a way to overcome these challenges. So we started thinking hard about how to do that. And our microgravity lilypond system is a hydroponic growth chamber for use in microgravity that hopefully, we're working on this now, we'll be able to grow water lentils as well as other small vegetables in this challenging environment.
So what are you hoping to learn from sending the microgravity lilypond into space?
Well, our microgravity lilypond chamber provides this controlled environment for these floating aquatic plants, including that stable water film that the plants can grow upon. And it also has a special harvesting method that separates the plants from the water so that when they're ready to be eaten, you can harvest them without taking all that water with you and then recycle that water back into the system and reuse it. So those water delivery and harvesting technologies had been bench tested in Earth gravity. We had tested those technologies for water delivery and harvesting in Earth gravity.
Yeah.
But the only way that we can really see if they work in space, in microgravity, is to send them there, even if it's just for a few minutes.
Yeah.
So through this flight testing, we're hoping to learn how that duckweed will mechanically interact with water. Is it going to flow through the plumbing, or is it going to get stuck? Will it stay on the surface of water? Will it become submerged? Actually, duckweed fronds have very special surface properties. It's kind of interesting that should allow them to stay on the water surface, even if there's no buoyancy from gravity.
Yeah.
So we want to test out that theory and see how the plants interact with that water surface. And also we want to see that we can get the water and the duckweed into this harvesting machine and show that we can successfully separate the plants out from the water. And also we really want to be able to see that we can deliver water to the plants on a growing surface and keep them there on that surface. And so we're looking at effects of things like the geometry of that growth surface and the materials, the properties of those materials, and how they affect how well we can hold on to that water without it flying off into the chamber.
Okay.
So many, many things actually that we are looking at in our flight.
So your experiment flew on a suborbital flight. So it wasn't in space for very long. I mean, I watched the mission live and it was fabulous, but it's only about sort of 10 minutes right from launch to the capsule coming down to the ground. So are you planning to run a longer investigation for the microgravity lilypond?
Absolutely. Yes. So the lessons that we learn on these short suborbital flights that are only a couple of minutes of microgravity are really valuable, though, and those will help us to improve the chamber design and the design of that growing surface to make sure that we have the stable water film locked down. And those short flights will give us a higher chance of success during those extended operations, during more extensive testing. So certainly our next step would be to test the technology for much longer durations on the International Space Station or any other space stations that may become available in the future. So we are hoping that our partners at NASA will agree with us and provide us with that opportunity.
Yeah. So Spacelab is also working on another project that's called the Mars Oasis. So what's that about?
Oh, we are very excited to have been awarded a contract to develop the Mars Oasis. What this is kind of what it sounds like. It is a greenhouse designed for Mars.
Right.
The greenhouse takes advantage of the sunlight that you get at the Martian surface, and it supplements that sunlight with low-power LEDs and solar panels in order to grow plants and keep them warm with as little electricity as possible on that Martian surface. Inside, it would have vertically stacked growing trays, kind of like an indoor vertical farm that can also operate continuously on sunlight and not rely on LEDs.
Yeah.
But the special thing about this greenhouse is that it can be stowed in a very small space while it's traveling to the planet and being transported. And then when it arrives at the planet surface, it would be inflated. And then that surface of the greenhouse would harden over several days so that it becomes strong enough to withstand that Martian atmosphere and the difference between the pressure inside of the greenhouse that you need for your plants and atmosphere that's outside in the Mars environment.
That's really clever.
Another aspect to this greenhouse is CO2 provision to the plants. So we are working with our partners at the University of Colorado at Boulder, and they are developing a novel method for capturing CO2 from the Martian atmosphere, which has a very high CO2 concentration, and delivering that carbon dioxide into the Mars Oasis greenhouse for the plant's consumption. We are developing a prototype of this greenhouse actually over the next year, and we hope to eventually demonstrate that technology on the surface of the moon. Maybe even hopefully on an upcoming Artemis mission. Who knows? We'll see. Then we would change the name of it though to Luna Oasis.
Yeah.
Look out for that. And also one more thing about this technology is that it could be used on Earth.
Yeah.
For more energy efficient indoor farming, and for better means of sequestering CO2 to enhance plant growth in an environmentally friendly way.
Yeah. Okay, so that's really interesting then. Yeah. So you're designing for space, but it will work on Earth as well.
We always hope that whatever we design for space, if it helps us to have a more sustainable presence there, and then hopefully it will improve our efficiency for our technologies here as well. That's always an extra goal for us.
Absolutely. So can you see duckweed taking off as food on Earth as well?
Oh, very much. In fact, I think you might see that soon.
Fingers crossed.
I think it is. Yes, I think it is starting to take off. There is one company in the U.S. Who has the first duckweed-based plant protein that is on the shelves and on the market right now.
Oh, okay.
It's a duckweed-based plant protein product. And there are some other companies internationally as well that are developing duckweed as a food product for people. It has been a food for livestock previously. It's also used a lot for wastewater treatment systems, but the benefits for human nutrition, I think, are just becoming more evident, and more folks are starting to realize how valuable this plant might be as a potential food source for people as well. So I think we might see it as the next superfood.
Absolutely. I shall keep an eye out. We here in the UK, we're usually, a little bit behind you in America, so you'll get it first, and then maybe we'll get to try it as well.
Hopefully it will be on the shelves right next to your spirulina.
Okay, so on a more personal level, if you were going into space, you were joining a colony on the moon or on Mars, and you could only take one plant with you, what would you choose? And you can have your duckweed because that's part of your life support system anyway. So, but this is a personal plant. What would you choose?
That was an extremely hard question.
It is.
But if I had to choose right now and I were going and I had to grab a plant, and if it's my last plant, I would be able to hands down, I would take my miniature orchid.
Oh.
Orchids are a beautiful plant, right? And they're calming. I think that would be very important.
Yeah.
In a stressful environment like a spacecraft or a space habitat. My miniature orchid that I have is this deep purple color, and that's my favorite color. And it's little, right? So it doesn't take up a lot of space. I could just kind of keep it in the corner and have it there with me. It doesn't need a lot of my attention. And actually, I have this orchid that I have cared for several years, this little miniature variety. And I've gotten pretty attached to it. So
yeah, that sounds
I would
lovely.
want to take it with me. Another cool thing I think about that orchid plant is when I started reading about how to care for them. I kind of think of them as innovators themselves and survivors. Because they have adapted to grow in a very strange way in an unpredictable environment. They collect humidity out of the air into their roots. So they have some interesting adaptations and have found the novel ways to survive. And I think that's inspiring.
It is. That's brilliant.
I would take my little purple.
What an awesome choice. And I have to say, purple is my favorite color as well. So, yeah, I'm with you on the orchid. That's wonderful.
I just had another thought about microgravity lilypond that I should probably mention. So not only does the microgravity lilypond growth chamber support aquatic floating plants like duckweed, but because we have these very closely vertically stacked trays and lighting panels inside that growth chamber that are close canopy lighting. We can have a lot of trays stacked in a very small volume. So it's kind of like a miniature vertical farm inside of that growth chamber. And also it will be a very good platform to support growing vegetables like microgreens as well. So once we have demonstrated this ability to support duck, that's going to be our next step with this growth chamber, is to actually start testing it with other kinds of crops as well.
Yeah, I think that would be really great, because with microgreens you get such a nutritional punch, but you also get the flavor, which I think astronauts are really going to enjoy. So yeah, you're more bang for your buck. Okay. Thank you, Chris. Thank you so much for coming on the show and sharing your wonderful research with us. I also wanted to say a big thank you to Gigi, Christine's executive assistant, for setting up our interview and for sharing her fantasy space plant with me. If Gigi was joining a colony on the Moon or on Mars, she would take her lemon tree with her. How wonderful would that be, to pick your own lemons in space? If you'd like to share your fantasy space plant, you can send me an email. The address is earth@spacebotany.uk. Just let me know which plant you'd take with you into space and why. That's it for this episode. You'll find the show notes on my website, theunconventionalgardener.com, which is also home to a virtual tip jar for those of you who would like to support the show. And if you want to become a regular supporter, you can sign up via patreon.com/Gardeners of the Galaxy to gain access to extended episodes and bonus content. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control, confirming termination of your signal. We have spoken to the engineering team about the smell you've reported, and they have requested that you try stirring the WC tank. Mission Control out.